So just a quick video tonight showing footage taken on a recent flight from Broome to Sydney in Australia. During this flight, the moon rose directly ahead of the aircraft, allowing me to make an observation that would not be possible if the Earth was flat. And to understand this, I'll just revise some of the key head-up display symbology. The main one being this HUD horizon line, which shows the position of horizontal from the aircraft. This is the 0 pitch reference line. We can see 5 degrees up and 5 degrees down here, and the actual pitch of the aircraft is shown by this indication. The difference between this indicator and the 0 pitch or HUD horizon line is the pitch attitude of the aircraft. As you can see, the moon is clearly below horizontal. Now, if the Earth was flat, that means the moon has to be lower than the altitude of the aircraft, which is currently 45,000 feet. And it also means that the moon could be no more than several hundred miles away. And clearly, that is nonsense. So during this part of the flight, the aircraft was holding a steady 45,000 feet altitude. It had a vertical speed of 0. The flight path vector, indicated by this circle, shows exactly where the aircraft is going. If it is on the HUD horizon line, then the altitude remains constant. If it is above the HUD horizon line, then we're climbing. And if it is below, then we are descending. The relationship of the pitch attitude of the aircraft to the flight path vector gives us our angle of attack, which we can see down here in the angle of attack indicator, showing 2.3 degrees. The pitch attitude is 2.3 degrees above horizontal, and because we are in steady cruise flight at a constant altitude, the flight path vector is also on the HUD horizon line. But that is not always the case, and you'll see later in this video, when we are landing, just how useful this flight path vector can be. So I'll play these clips now in real time, effectively destroying flat Earth once again by showing the moon below horizontal, a position it would never be seen on a flat Earth from 45,000 feet. And after that, we'll take a look at some footage during the landing approach just to explain how useful this flight path vector is and talk a little more about the relationship of angle of attack to the pitch attitude. So this clip was taken during the final approach to runway 34 left at Sydney Airport. Now we are configured with full flap and back at an airspeed of 115 knots. And that means we have a high angle of attack, 6.1 degrees. You can see the pitch attitude of the aircraft is actually higher than 2.5 degrees, but the flight path vector is below horizontal. And that means we are descending. We're descending at around 600 feet per minute. What you will notice is that the flight path vector is in line with the PAPI, and that's the Precision Approach Path Indicator light. As we get closer, you can see the PAPI on either side of the runway. They are 4 lights to the left and 4 lights to the right. And if you are on the correct approach angle, you will see 2 white and 2 red lights. If you are slightly low, you will see 3 red lights, and if you are too low, you will see 4 red lights. But what you will notice is during the landing approach, the flight path vector is showing us where the aircraft is actually going. And if you hold that precisely on the PAPI lights, you will arrive at the runway at exactly that point. I just want to say that the landing was actually very nice. The only reason it looks rough is because of the way I was holding the phone. So my apologies for that, but please enjoy the landing approach into Sydney International Airport.
Minimum.
That's checked.
100. 50.
100.
30.